All right, so what we're going to look at today, we're going to take a look at linearization. That's where we're going to take any equation and write it in the form y is mx plus c. Okay, so we're going to take a curve and put it in a straight line. So I'll give you a real easy example, right? Right? Let's see if we can linearize. Let's see if we can linearize y is equal to x squared. Let's see if we can convert that into something linear. Right? Here's what you're gonna do. Right? And normally I would give you something like this, and after the plot it, I'd give you x and y values. I'll tell you when x is 0, y is 0. I'll tell you when x is 1, 1 squared is. When x is 2, 2 squared is. And so on, right? And you will plot it and connect it up. And that's what you normally do. Right. But if you draw this, you're going to get that. You're going to get this, right? You're going to get curve. Right? Well, you're going to get, if you use these values, you're going to get something like that. But I don't want that. I want to get a straight line. Okay? So what we could do is we could do something called linearization. So we could take logs on both sides. So you'll get log y is equal to log x squared. That's okay? I can take the 2 and bring it in front, and I'll get log y is equal to 2 log x. Hear what it's saying, right? Right? Hear what it's saying. This saying that log y will be a new y-axis. Your new x-axis will be log x. And if you do that, your gradient will be 2. What does it say about the y-intercept? Seen any? No. So it means that the y-intercept is 0. So the line is going to pass through what? The line is going to pass through the origin. So your line will look like this. Your y-axis will be log y. How again log y? I'm going to calculator and I'm finding log 0, log 1, log 2. Right? And I'm going to plot it against log x. And I'm going to get a straight line. And when I find the gradient, it's going to be 2. So I took a curve that looks like this and turned it into a straight line. Right? In some areas, a straight line is more useful than a curve. Okay? I can tell you relationships a little bit easier. Are you okay with that? Right? So this is the concept of linearization, right? Right? Of course, I'll give you an example. So normally what I'll make you do, Brandina, what I'll make you do is I'll make you sketch this. So I'll make you log these values, put it in a graph, and then find the gradient. I'm going to reach here and give you a small note. In the video, log it. Right, so I can do something, right? Whenever you're linearizing, I want you to note that your gradient, M and C, right? Your gradient, M and C, must never contain X. and y, or whatever variable I give you, right? It must never contain whatever variable I give you. So your gradient and your y-intercept must never contain x and y. Online, you're okay with that? Serena, Anya, you're okay. Armin and Naya, you'll follow what I did here. Right? When you finish a way to linearize this. Okay? Please remember this, right? Your gradient and your y-intercept must never contain x and y. Okay? So way to linearize this somehow. Right? Tell me what we're plotting where. That's the same thing. Take your time, right? Linearize. Online, all I want you to do is tell me what you get for your gradient and what you get for your y-intercept. With y, with m, with x, and with q. Right. Oh, yeah, keep blocks on both sides and break it up. Right, everything down there. We got loops, and my C must have a one A and with y, with m, with x. You do all the hard work already, everything you want to do. Do it first. Right, but tell me what is y, tell me what is m, tell me what is x, and tell me what is c. Some of you are doing it good. Right? Some of you are doing it good. I just want to see what is y, what is m, x, and c. Here's what important. M and c must never have x and y. Okay? M and c must never have x and y in it. Never have x or y and or. Right? Never put and or. Okay? All right, let me see some answers coming there. I am now looking so bad, Nerissa. Right, so you're taking logs on both sides. So you'll get log y is equal to log a b x. Then we're going to split it up. You'll get log y is equal to log a plus log b to the power of x. Then we're going to bring the x in front. Right, this is looking a little confusing, so let's just rearrange it. Let's leave the y here. Let's bring the x term here. And let's bring the next log part here. This is a constant, so we know that is c, we know that is y. Okay, all we had to figure out now which is the gradient of which is x. So I have x multiplied by log p. I told you that the gradient can never have x or y in it. So this cannot be a gradient. That's x, and log b is a gradient. Right? So therefore, if you have to plot, you're going to plot log y against x. When you sketch it, your gradient will be log b, and then your y-intercept is log e. Right? You can't plot the graph today, or I'll do it next week. When we plot the graph, I'm going to show you how to find A and B. A and B are unknowns. Right, girls, follow what went on here? Follow what went on here? So when I rearrange it, I put it in the form y mx plus c. Okay? Give you our next one. Any questions online? Javi, any questions? Good. All right. Try this next one here. Let's do that one before I go on the board. Hurry up. Come on the board and do that one. Oh, yeah. Do that. No, that's not right. For the rule of study. M can never have access. Right, message answers online, Anya. Message answers. Yep, all the time. This next dumb one to what's your name? Sharpie. You might hold the cameras and doing some kind of sign. Yeah. Who you doing? That's all he doing. All the cameras, no, you walk around. Some kind of thing, I don't know. That's what I just seen him going by. Every camera he going by. Yeah, this one half here, but this one next one coming. I'm doing something special. With some different special. It's for like facial recognition. This one. I will be watching you in class and seeing how you're doing and send a report. Create a report chat on the child. Something I try. So you can look. So for example, if a child lost in class, I can go back and see if you're actually looking up, not paying attention. Yeah, you do. No, I will have to train it how to do it. Yeah, camera to do all that. Right. Right. Oh, yeah, we should finish what I said, right? So you'll get log y is equal to log exp. So that'll be log y is equal to log a plus log xp. Right? This will be log y is equal to log a, sorry, plus log, bring the b in front x. So I just bring it here. So that'll be b log x plus log a. This is your y. This is your x. This is your gradient. This is your y-intercept. So if I plot, I will plot log y versus log x. When I do my best fit line, my y-intercept will be log a. And my gradient will be equal to b. Very good. Right? All right. Here's what I'm going to do, right? I'm going to give it to the same one. I'm going to pretend that we go through the graph. Right? I'm going to give you some points and I will tell me what is A and B. All I want you to do is tell me what is A and B. So it's the same thing. We're not drawing the graph, right? I just given you a sketch with some points on it. Right? And we plot same thing, right? Log y versus log x. So when I give you the values and you draw it, this is the graph you end up with. I want you to find A and B. Right? Find A and B, and you're using this info here. Right? B is equal to what? B is the gradient. So all you have to do is what? Find the gradient here. A is what? Well, log A is C. So you write log A equal to C and then solve for A. Sorry? Because here's why I put B in front of log X. Because the B went here. Oh. Right? So I just bring the log X on that side. It's always y times x plus c, so after the x after the equal sign. Right, see if we can find A and B there. Find the gradient and then find E. Hurry up. Right, we don't have much time to sketch. So keep a graph paper. Whoever doesn't get the free graph page, keep it. Right? And next week we'll actually plot one, right? And I'm giving you back that same test again next week, yeah? I'm giving you back. I'm giving you logs. I'm giving you back the log test. Remember, I have to give you a whole section one test, right? That we completed section one. Okay, that's a 4. How do you know you're blind and you're going so so far? That's a 4, yeah. 4 and 7, 4. Online, tell me what you get for E and P. E might be a little tricky, right? But well, find the gradient and then do the next part. Well, give you bad value. So I did. So the X value, wait, this don't make sense. This is that's 4, 7. It was 4, 7. It looked like why it looked like 7, 4. That's very 4, 7. I'll back. Oh yeah, make another take it for. Oh yeah. Find the gradient and do the y-intercept. This will be 4, 7. Yeah, sorry. Plenty. You can check on that in the elements. You do have logs. Collapse all and see. Send the C to the log. I don't know the split it up. Even if it's not there, huh? Right, so you can there's only one thing. Well, you can go on the school you yeah, go on live. And go on live and you will see it. Unlock up all these things. All I'm gathering. Some people just listen. Right. So we know that the gradient is what? Y2 minus Y1 over Y2 minus Y1 over X2 minus X1. Yeah. Yeah, 3/4. And we know based on this gradient is B. So therefore the gradient is B. So B is 3/4. B is 3/4. That's okay? Right. Here's the problem though. We know that log A is what? Log A is what? Log A is the y-intercept, which is 4. How are we working this out? How are we doing that? We should tell them one time. How are we doing this? I'm gonna give you a hit. I'm gonna give you a hit. Log to the base 10 of A is 4. Huh? You gotta just convert to the exponential form. So A is equal to 10 to the power of 4. That's all. Yeah. If I put 10 to the 4 here, if I put 10 to the 4 here, and the 4 go in front here, and you'll get 10 is 1. 1 by 4 is 4. Right? LG is 10. Log to the base is 10. That's the first thing I wrote in the class. That's the first thing I wrote. Right? So to go from log A is 4 to here, all we have to do is write the A, bring up the 10, carry across the 4. 10 to the power of 4. All right? So that's the answer. You can leave it like that. You don't have to write 10,000. All right, online? So that's the start of indices, right? We'll continue to do indices. That's the start of linearization, sorry.